Thanks for coming. Lovely to be here. I'm so happy to be at in-person conferences. Not that online conferences aren't wonderful. For one thing, like, it is really amazing to be able to go to conferences that aren't going to fit in your travel and time schedule. So that is an amazing thing. And the other amazing thing about online conferences is, I don't know, I'm really tired of them.
Well, I just
I'm
want
glad they exist, and they needed to exist. I'm really glad that we were able to continue doing what we did in a time when nobody could get anywhere or talk to anybody outside.
I just
of
want
their home.
everyone to know that it's not quite true. Chet hates doing online conferences because he misses the adoration from the audience. So he refuses any online conference. That's why you didn't see him at Google I/O this year.
What is the point? The point is the people. So please, thank you. Lovely to be here, and lovely to see everybody here again. Today, we got a couple of talks. We're going to start talking about why projects succeed. In particular, we're going to take a look at elements of Android and how Android came to be, a little history lesson, and some of the elements that contributed to Android's still being here many years later, and then sort of try to distill some ideas from that and look at why maybe generic projects could succeed. A lot of that is obviously unpredictable, but there are some lessons that we can draw from that.
It's a bold assumption to say that Android succeeded because based on what I read on Twitter and Reddit all the time, I'm not so sure.
I like to say not so much that Android succeeded, but rather we're still here. We're still here, and that's pretty cool. By the way, I'm Chet Haase. I work in the Android graphics engineering team.
And I'm Romain. I work on the Toolkit team.
And we have been doing that for a while here. Oh, we have a pretty animation. Look at that. I made that all myself. So
Hey, don't set the bar so low for Chet, please. Like, don't encourage him.
I heard at least one clap out there. Or maybe it was just an awkward cough. So a lot of what we're talking about today comes from a book that was published last August and is currently unavailable because it's being republished in a different edition by a real publisher and not just me.
You can say you wrote the book instead of just saying a book happened to be published.
A book happened to be published by someone somehow. That is shipping tomorrow, actually, from No Starch Press. So originally it was available in all these places, and this is no longer true. Instead, it is a No Starch Press edition with some new illustrations by Dan Sandler, yay, and an audiobook, which should also be coming out soon after entirely too long recording and editing that stuff. All of the profits from the book do go to tech-related charities. Currently, that's Women Who Code and Black Girls Code. I'm happy to support them. So this is not about royalties for Chet. This is about people getting to know the story of Android. I wrote it because I thought it was really interesting, and I wanted to help share it.
I mean, you keep saying it's not for you, but you never showed me proof.
I'll get that to you real soon. So first, let's talk about history.
All right, so we gave several talks about the history of Android. I think we gave one here a few years ago, and we have a long timeline of computer history. Of course, the only part that matters is Android all the way over there. Everything that came before, details. So this time we're going to do something different. We gave the talk that we gave on the history of Android kind of started around Android 1.0, and here we're going to talk about what happened before that. So it's the prequel. All right, so first up, Android started with cameras. How many of you knew that? All right, a few. That's good. Good students. So Andy Rubin, which founded Android, started the company in 2003. It was called PhotoFarm, and the idea was to build an open source platform for digital cameras. So 2003 was a bit early still, but digital cameras, DSLRs, were starting to become good, for some definition of good. And actually it's funny because Chet and I were just complaining about Google Drive earlier, and I love that story. I have files that I took with digital cameras from the early 2000s, and Google Drive refuses to sync them because they're too small. Like, I kid you not, that's the error message. My photos are too low resolution to be synced. Anyway, so cameras were apparently good enough back then. So Andy Rubin and his partner Chris White, who both worked previously at Danger. So Danger, for some of you who may not know, was a company that made a device called the Sidekick, the T-Mobile Sidekick, which was a very popular messaging device, especially in the US. all the way back then. And so they wanted to build this open source platform to give users of DSLRs a better UI, better software, and to unify the experience across all those devices. And like I said, they worked at Danger on the T-Mobile Sidekick. And Danger is going to come back in a little bit.
So they had this idea, and they said, we're going to make cameras better. And they went around the valley, up and down Sand Hill Road, and pitched it to investors who really couldn't have cared less. There were a couple of reasons for that, one of which was cameras were starting to be incorporated into even some of the feature phones at that time. So as a venture capitalist, you have one job, which is to make as much money as possible, and they couldn't really look at this project and understand how that was going to happen. So nobody picked them up on it at all. At the same time, a couple of people that Andy had worked with when he was at Danger were Rich Miner, who ran a venture fund that invested in some of that stuff, and Nick Sears, who was at T-Mobile, which was the launch partner for the T-Mobile Sidekick, worked with Danger on that, and they said, hey, that whole camera thing, what if it wasn't cameras? What if it was phones? And Andy said, I don't want to do phones. I already did phones. I want to solve the camera problem. They said, okay, well, call us when you want to do phones instead. So he happened to bring it up at one of the VC meetings, and the ears in the room finally opened, and people said, oh, well, that might be interesting. So he changed his mind. Okay, maybe this is the way to make things happen. So Nick and Rich joined as co-founders and helped develop a business plan and a slide deck, and they pitched that instead.
And so that's what the team, that small company, was doing through 2005. And here you can see on screen a couple slides from the pitch deck that they were using with the various VC firms that they were visiting. And on the right, you can see some of the facts they were using to make their pitch. The idea, and it was very true back then, was that phones were taking over, right? Not just the feature phones, but also smartphones were starting to become a thing. And the volumes were much, much higher than PCs at the time. And on top of that, the hardware for those phones was starting to become really good, right? We were getting the equivalent of a desktop PC from 1998. GPUs were starting to become a thing in those phones. We were starting to have 3D games and so on. So they were not quite there yet, but anybody who was working in this domain could tell that within a few years we would have what we now have. And the only thing that existed back then, so the manufacturers either had their own platform, so you can think of Nokia, for instance, they had Symbian, or you could use Linux. And it was, I think, the Linux Open Alliance, something like that. But basically, it was more of a spec, which would tell you, okay, what version of Linux are you going to take, which libraries are you going to take. So it was not a vertically integrated stack. It was more a loosely connected collection of libraries and tools, which was greatly helpful, right? Like you didn't have to write everything from scratch, but it was a far cry from having an operating system ready to go, an ecosystem of good applications, and you still had to deal with the carriers, the monetization, and all that stuff.
It's like those advanced math books where you get to something and they make some statements and you're like, well, how did they get? I have no idea how this works. Let me look at the proof, and the proof says left as an exercise to the reader. That was the Linux operating system solution at the time, was like, well, here's a little bit of stuff, and then you go off and you create the drivers and work with 40 different manufacturers to get the rest of the system. And that basically didn't work for anyone at that time. All right.
Yeah, and so with this new pitch deck and the help of the newcomers on the team, they've been pitching to various VCs, and I think they went to the East Coast, if I remember correctly, and it was more successful. So 2 different firms offered the team funding, but at the same time, they happened to talk to a company called Google, who had recently IPO'd, and Google, instead of deciding to invest, just offered to acquire the company entirely and to move all development internally to, do what became Android.
So I saw discussions online and some, I don't know, book review or Reddit or Twitter or whatever, people saying, well, Google bought this company and then they shipped the phone that the company had, which is basically the opposite of the truth. What Google actually bought was
I think
idea.
Nothing is really the term.
Yes. 3,000 lines of JavaScript, as somebody on the team put it. There was an administrative assistant who was helping out with things. There were the 4 founders that we mentioned. There were basically like 3 to 5 people actually writing code and doing designs on the product. And the product wasn't even a product. It was just a demo. What they really bought was the overall idea of what was going to happen, this open source platform for phones.
Yeah, and to me, that seems to be the real definition of success, managing to sell your company for a lot of money with nothing to offer for it, except you have an idea.
Must have been a
This
really
is not
good
how
idea.
it's supposed to work, I think. Anyway, but it worked.
And this is kind of what they came in with. This is the demo was, it wasn't even a phone. It was a picture of a phone running on a desktop, running JavaScript, looking basically nothing like what Android looks like today or even at 1.0. But it had some of the core ideas, certainly open source aspect of it, the full platform that they wanted to ship, and some of the ideas about what smartphones should do, the kinds of data that they would enable, the persistent connection that you would have to back-end data like stock ticker and calendar.
I think you're overselling that demo a little bit, because I've run that demo a few years ago. That it wasn't that much.
No, it was not. Yeah, and as Hui, he worked on some of the early messaging application stuff and is still around. How did you sell this company to Google for just a bunch of JavaScript? We'd love to know. We've never had that happen to us, but it worked out for them.
All right, so after this acquisition, in 2005, again, the team had nothing, just a few engineers and founders, actually more founders than engineers, which is also a weird way to build a team. Anyway, so the team had to build the entire OS. So what does it mean exactly? That meant building a kernel. So Android uses the Linux kernel, so at least we didn't have to write the kernel, but then we had to write the drivers, right? Because when you start an operating system from scratch and you basically don't exist, no one will write the drivers for you. You can go to the manufacturers, to your GPU manufacturer or your modem manufacturer, you can ask for a driver and they will just laugh at you. So the team had to build all those drivers from scratch.
And then on top of that, you have the language, which at that time was 3 languages. It started out as JavaScript, and they said, well, what's really good on very limited devices at that time, and even to some extent today, is C and C++. That's what embedded code tends to be written in. You really get full control over this. You're as low level as you possibly can be, besides assembly code, which the team also really loved. It was a bunch of embedded engineers at that time, so they said, okay, well, we got JavaScript, and we'll obviously do C++, and then I guess there's this Java programming language thing, so why don't we do all 3? And then at some point that year, this is late 2005, someone realized we have 15 people on the team. Why are we supporting 3 languages? Let's just get the thing done. So they decided, okay, 1 language, let's focus on Java, the programming language, as the source of all the APIs, and all these other things are not going to be a priority for the team.
And the main reasons for picking Java were pretty simple and very pragmatic, which is true of many decisions made back then. There were already millions of Java developers. Java was being taught at universities and various schools around the world. There were a lot of IDEs that were free. For instance, you had Eclipse for free, the SDK was free, and there were tons of libraries. So it made a lot of sense to pick something like Java because it was accessible and a lot of people knew it. So when you were trying to build an ecosystem, relying on something that you already know, and I'm sure some of you, might have started this way. That's what happened to me when I joined Android. I was productive from day one because I already knew how to write Java, so I didn't have to learn anything new.
Of course, if they're going to support the Java programming language, then you need a runtime. So they worked with a couple of open source runtimes at that time for class files, but then eventually they wrote Dalvik to support this new runtime for the DEX codes that we run instead, and on up the stack we go.
And the language and the runtime obviously are not enough for applications to be built. So you need the framework, you need the UI toolkit, the graphic stack, the media stack, you need the system UI for the user. So all those components, and that's where the vast majority of the team was working. It was building all those massive components, and it's still where I think the majority of the Android team works on nowadays.
It was clear that any smartphone platform at that time needed to come with some powerful applications. Out of the box, the intention was always to provide the ability for other people to write applications for the platform. But Google had some pretty interesting and compelling applications, both on desktop and on some of the nascent smartphone and even feature phones at that time. So they needed to provide things like Gmail, Contacts, Calendar, Maps was kind of a killer app and continued to be even more so. So the team, now note, this wasn't just Google building these apps. The rest of Google, A, didn't really even know about Android. It was still a secretive project internally. And B, if they did know about it, they honestly did not care. They could either spend their time working on applications on phones that were actually shipping, or they could believe that maybe sometime in the future Google would have a platform that might matter. Why would they spend their time on that? So the Android team itself wrote all these applications internally.
And the reason why those apps are a lot better nowadays, besides 15 years of development, is because there are actual teams behind them and not, random engineers from the Android team. I personally wrote code in all of those apps, and that was not my job, right? I was working on the UI toolkit, but someone had to help, and everybody was helping. So we did what we could, but it was interesting because since we're creating something from scratch and we control the entire stack. A good example, I think, is Gmail. The mobile team at Google back then was working on Gmail for those feature phones or for BlackBerry and so on, but they were limited by what those platforms were offering. So Android was able to come up with the push notifications, which made instantly the Android version of Gmail better than all the other platforms, which was interesting because we were not even the Gmail team, right? Of course, we worked with them. They did the backend side of things, although I think we helped as well with the backend. So anyway. And then on top of the applications, the applications need those frameworks and runtimes and APIs. We also need all the services. So the window manager, the media service, the photo manager, the contact service, all those things that your apps talk to that help you connect with the system as it runs.
And then you have Android Market, a place for applications to actually be uploaded and sold. This is, as I said, the original intention was to have an application store and make it as easy as possible for developers that didn't happen to be on the Android team at Google to write applications that could be as full-powered as all the applications that were being written internally. This is why they were exposing public APIs. It wasn't just, let's write a bunch of apps and let's sell our smartphone products. It was, let's create a platform and make it possible for everybody else in the world to write killer apps as well.
And finally, we needed the SDK, so to package the compiler, the tool chains. We also had a plugin for the Eclipse IDE, so something to make it easy for you to write apps. And it was interesting. Just yesterday, actually, to prepare for our talks that we're giving this afternoon, I opened an old project of mine that happened to rely on the very first public version of Android Studio. So it was a lot of fun to migrate the Gradle file from that version to what Studio supports now. It took me a good 30 minutes. But yeah, we didn't have that, right? I think we're using Ant as the build system, so Eclipse as the IDE. The emulator was already based on QEMU, but a lot of things were quite different in the SDK. And the SDK was a tiny team.
Okay, so we're in the run-up to 1.0, and then all of a sudden in 2007, this thing comes out called the iPhone. So in January, the iPhone was announced, and then in June, the iPhone was actually available for people to have. And note, again, nobody knew about Android at that time. This is pre-SDK. It was a secretive project internally and certainly externally, and now the iPhone is out. And there were some interesting dynamics that came about there. And one of them was that all of a sudden, touchscreens went from being a technology that already existed in various form factors, including other nascent smartphones, but it was done in such a way that both consumers and manufacturers all of a sudden put that as a checkbox. Well, if it's going to be a smartphone, it needs to have touchscreen capability.
So interestingly, I joined the team in March 2007, and again, the project was secret. So I actually joined, I think I was on Google Books for like a week, hated my life. Thankfully, there are people over on Android who knew me, and they're like, you should come over, like, we can't tell you what we're doing, but you should talk to us. And I remember when I was talking to the lead of the team at the time, he showed me the Sooner device and what became the T-Mobile G1, the Dream, so the touchscreen version. So already in March 2007, they already had hardware and they knew they were going to build that device. So iPhone accelerated a lot of things, but touchscreens were already on the roadmap.
But what it did do was it changed the ordering of the product map. So the Sooner device was going to come out sooner. This is basically the equivalent of the BlackBerry at the time. It was a little non-touchscreen with a keyboard that was omnipresent, and that's how you were going to interact with your phone. That was going to be able to come out sooner because there was less to do with it. And then the second phone that the team was also working on was called the Dream, and that was going to launch later as the G1. And the decision after the dynamics of the industry changed was, okay, let's kill the Sooner, because if we come out with a BlackBerry competitor after the iPhone is out, we're not targeting the right market.
Sooner became the Never.
Yes.
And the Dream, I think one of the reasons called the Dream, it was actually a pretty impressive package of hardware back then. So, you had this big capacitive touchscreen. There was a keyboard that you could unfold. It had a trackball, LED for notifications, had a GPU, lots of RAM, a fairly fast CPU, but it also had things like an orientation sensor, a gyroscope, what else? I think there was a barometer. So there were a lot of cool sensors, like things you would not get in other phones, or that you would not get access via the APIs of the platform. And so that was a big deal for Android to give you suddenly like all those cool features in one single package.
And then finally, in October of that same year, then the SDK launched. So now, as of October, Android was now a public thing. Developers could download the SDK, could play with it, could work with the emulator. Interestingly, the first couple of emulators that were in the SDK look like the Sooner device, but they actually have touchscreen capability. So it's a bit confusing until they finally came out with emulators that looked like what you were going to get in the final launch.
Yeah, you should have seen how the team was trying to implement some of the early touchscreen capabilities because we didn't have enough devices for everybody, or they were not quite working. So we had those like 15-inch LCD touchscreen, like the kind of touchscreens you find like at the supermarket or places like that, and they would be connected to your PC, and you would run the emulator on that, and like it was those not capacitive, the other one, what are they called? Resistive touchscreens. So a horrible way to develop touchscreen capabilities.
I think they use those now as the movie screens in airplanes.
Yeah. Which happen to run Android, by the way.
Yes. Swipe up sometime and you'll
I
see
am
some
not worried at all
familiar
every time I'm
icons.
on an airplane and I see that my code is running in front of me.
All right.
So yeah, finally we made it. 1.0 comes out, so end of 2008. The T-Mobile G1, I'm sure you've seen that device before. It came out, so yeah, it was only on T-Mobile. We also open sourced everything, right? That was a big deal, and that was part of the vision from day one. We would give you the entire source code, except the Google private apps, things like Gmail, because they talk to our servers. But everything else was open source. The device you could buy in the stores, you could not only root it, but you could also unlock the bootloader. You could download the source code from AOSP, compile the system yourself, and flash your device and start developing on it. So basically, the customer device was no different from the devices that we were using internally, and the workflow was no different from what we were doing internally.
All right, so device launched, 1.0 is out there. Everybody's really excited about this new thing, and this is basically the explosion of excitement that happened with Android in the following year. You see that green line at the very bottom the entire year? That's Android. Everybody else is doing very well, thank you very much. Microsoft always does well in the software world with platforms. It's what they do. iPhone had come out. It was doing very well in a very consistent manner. RIM they had like loyal user base in the enterprise market. Nokia kind of owned both smartphone and feature phone all over the world. And then this new Android thing came out and didn't really do much for the whole next year.
I remember one of the happiest moments for the entire team on Android, in the past 15 years that I've witnessed, was when we were all in the meeting room, because the team was very small, and we were cheering because we had reached 50,000 users.
Not a big number in the phone world. All right, so then we get into 2010. So at the beginning of 2010, this is where the previous graph left off. I joined about 5 months into that in May. You'd already been there for at least a couple of months before that.
Yeah, I want to make it clear. It's not because of Chet or thanks to Chet that the numbers started going up.
Mere coincidence? I think not. All the people over there are still many chairs over here if you actually want to sit down. We're not going to shut up for a while, so you're going to be standing for a while. All right, so 2010, this is what the graph looked like after that. All of a sudden, the line picked up. So one of the dynamics was at the end of 2009, the Verizon Droid launched, and that was the first, I would say, successful consumer device, at least in the US. So all of a sudden, the team started seeing real numbers, not just 50,000, but like over 1 million users in the first few weeks or months or whatever.
Yeah, and it was partly because then there was the success of the iPhone, obviously, and everybody was trying to catch up, and some of the manufacturers were trying with their own operating system, their own stack. But slowly but surely, more and more manufacturers started trusting Android and started adopting Android when they saw that HTC, for instance, was getting success with Android. And then as the ecosystem was building up, it made more sense to adopt Android because then you get the apps. And if you get the apps, then we sell more phones and we get more apps and so on.
So one of the dynamics that you see here is what Hiroshi Lockheimer said was basically the industry spooling up. When they saw the G1 and some of the follow-on devices, then the manufacturers could see, oh, this thing is real and we can actually build on it. We can serve the needs of our customers. And so they worked on platforms, on their variations of the platforms and their devices in the background. And then all of that stuff started to hit in 2010. 2010. So it wasn't just the success of the Droid, but it was also all these other devices starting to come out all over the world where Android picked up. And like when I joined, there was a question of like, oh, are we going to continue to be in like third and fourth place forever? By the end of that year, people had stopped talking about the comparison of numbers because Android just...
And there's also a built-in lag because we're talking about hardware, so it's not like you can decide to move away, let's say, from Symbian to Android and be ready in 2 months, right? Like this takes at least, if you're going really fast, a good year, if not more. So if you look at this hockey stick that started in 2010, that means that a lot of those manufacturers were actually already working on that early 2009. So the decisions were made pretty early. But it took that much time for everything to come to market, especially because you have to do carrier certification. That alone can take 6 months, which means your phone has to be ready 6 months before, and because it's hardware, those are long projects.
So that's for smartphones, but it's also interesting to look at the feature phone market. If you go out a couple of years from there, so at the time that Android launched, the default decision for somebody to get a phone was feature phone. In particular, if they didn't want to spend a lot of money, smartphones cost a lot of money out of pocket immediately, and the data plans also cost a lot of money, right? And not everybody really wanted to foot that cost. But a couple of years into that, with the capabilities of smartphones, capabilities of the hardware, all the stuff that you could do from the applications shipping from Google and other platform companies, but also all the external applications, like, wow, this is a really amazing computer in my pocket. Maybe that justifies a little higher cost. But also all of those devices available all over the world in all these different form factors meant that the prices could come down both on the hardware as well as the carrier plans. And all of a sudden, the default choice for people buying a phone was no longer this device that could only make phone calls and texts, but could actually do all the smartphone stuff as well. And people were picking up Androids instead of feature phones.
So why did it work? So success was not guaranteed. Android was a tiny team working for a search engine web company. Feature phones were dominating the market. There were major companies, RIM, Microsoft with Windows CE and mobile and Windows Mobile. There was Nokia with the Symbian group. So Symbian was also used by Sony and Motorola and so on. So yeah, it was definitely not guaranteed. And in a way, it almost makes no sense that we succeeded. And it's interesting because even internally at Google, a lot of people did not believe in Android. And I can't blame them, right? We were like the tiny team going after all those giants. So it was really hard to see a path to success. And we knew that going in.
So small team, as we talked about, those 8 people coming up and then ramping up hiring, obviously, but even by the end of that year, there was only 15 people on the team. Even by the time the team shipped 1.0, there was less than 100 people on the team. There were already huge, incredibly successful companies out there, right? So some people will say, well, Google has deep pockets. Obviously, this project would succeed. How many companies have you worked with or do you know that have launched a thing that really didn't succeed, right? Like really well-known companies do this all of the time. It's not dependent upon that company having the intention to do that thing or having enough money to fund the project or the multiple projects that didn't happen to work, right? So the money didn't, it's obviously related to success, but it's not the reason. There were really successful companies out there, and then the iPhone launched on top of that, right? And that completely changed the dynamics of the entire industry, competitively and technologically speaking as well.
So there are 3 major reasons why we think the Android succeeds. So first off is the team. Chet mentioned that when we shipped Android 1.0, here you can see in green the total number of Android employees across time. So around when I joined, we had maybe 50 people on the team. So, with large sub-teams like 1 or 2 UI designers and 2 people working on the SDK and 1 PM. But what's more interesting is this dashed line. So that's the employees who came from the companies listed here. So Danger, which was very successful building some of the first connected smartphones. B, Palm Source. So BOS was an operating system that never quite made it, but that was highly regarded, and it came out in the late 90s.
Cult. It was a cult classic operating system.
It's a cult classic. Awesome operating system, never took off. Big bummer. It was acquired by Palm Source, which was a spin-off from Palm itself. So Palm Source was building the Palm operating system, and they bought BOS to modernize Palm. So a lot of people transferred from BOS to Palm. And then we have folks who came from WebTV, which was an acquisition from Microsoft, and they were working on set-top boxes, so connected set-top boxes, with many similarities with Android, with smartphones, right? Connected boxes that are trying to do media. So there were a lot of folks who had prior experience working on operating systems. Some of them had been successful. A lot of those projects were not. So the teams had very good ideas on what they should build, what they should not build, and also where the industry was headed, right? So for instance, Diane Hagborn, I'm sure you've heard of her, she worked at PalmSource NB, and since day one, she knew that there would be high density displays. So in the system, she built in the device independence capabilities that now we use all the time, right? Like these DP units that you use all the time, because we didn't need them for Android 1.0, but it was clear that we would need them later. So they were able to anticipate a lot of those things. They could not anticipate everything, but a lot of things. And actually, it's funny. I don't know if you can find this article, but if you look up Diane Hagborn and Binder, you can find an article she wrote about Open Binder. So the binder that you have on Android, this IPC mechanism that we use throughout the entire system, came from or is derived from something that I think she built at Palm, if not at B.
I think it started at B, maybe?
So it's a more limited, more lightweight version of that, but it's interesting to see this article from 2003 or 4 where she describes something that we still use today on Android.
I don't know about your careers, but I feel like I've been doing the same exact, probably 10 lines of code for my entire career. We all just repeat.
I want to make it clear that it's not just a feeling, that's what you've been doing, and it's a scam, and you should be punished because you've been selling the same shit every year to different companies. You've done it at what? Sun, Adobe, now Google?
Yeah, it's working. Yeah. I mean, there's still bugs in those 10 lines, but...
Yeah, and somehow every time you say, but this time I'll do it right. What the hell?
Yep, not quite. Because then they wouldn't need me anymore. So one of the dynamics of that team was that it was incredibly small and focused, and very purposefully so. So not only did they start with a small team, and yes, they ramped up, but they didn't ramp up to a huge team until many, many years later. But they kept it siloed from the rest of Google, and I think that was kind of key at the time. The rest of Google was building web apps, they were building server stuff, they were building network stuff, and they had a completely different focus. Like the tools that they used, the infrastructure that they had, the practices that they had, the meetings that they had, the timelines that they had. Like if you launch a search feature and then you realize there's a bug in it, you can fix that bug today, right? You just launch again, and there it is, and everybody running search will get your fix immediately. That is not the case for hardware. Obviously, it takes a long time, as Romain was saying earlier, a long time just to build the thing to ship, and then once it's out there, it's out there. You can't update it necessarily, right? So it's a completely different dynamic. And the team realized that, and they said, okay, well, we're going to have incredibly tight timelines. We have different partners to work with, different infrastructure, different kind of tools that we need to build, and we really don't have the time to figure out this whole Google thing. And so instead, we're going to basically brick the team in. It's like the cask of Amontillado. We're just going to put them in the room, and they're going to work really hard on this thing. And they did. And one of the things to realize, the team works amazingly hard at that time, but it was self-driven. It wasn't management saying, thou shalt come in this weekend. It was everybody on the team knowing that they were on this mission. They knew that there was this really small window of opportunity that if they worked hard and managed to succeed, that they could actually hit that window. And so they were all driven to do that, driven really unhealthily hard. It was this nice Ficus quote. Yeah,
the currency of Android was working hard. Putting in a shitload of hours was very valuable culturally. And it was, but like Chet said, it's also because the team was tightly knit, and so everybody really cared, and the success of the project depending on everybody. And that's how I mentioned earlier. For instance, I personally worked on some of the apps, and other folks did similar things, right? So Matthias, who wrote Surface Flinger and the OpenGL pipeline, also wrote the audio mixer and the sensor manager. Why? Because someone had to do it, and he's like, I'll do it, I guess. So yeah, that ended up creating a lot of hard work. And while we're not asked to work on weekends, I still have a bit of PTSD, getting those texts on Sundays, Sunday evenings, where my boss was just saying "YT ? You there?" And you're like, "Oh crap! There's a bug coming my way." You could ignore it until Monday, but you cared.
So there were also several decisions. So some of the decisions that the team took early on and as the project developed that were contributing to the success, the eventual success. One of those was the technology. Romain mentioned this in terms of the density independence that Diane and others built into the platform. But there was across the board sort of understanding that there will be other platforms, there will be other devices built by people who are not us, who are aiming at a different thing than we're thinking about in the Sooner or the G1 device or the follow-on devices. And we need to build in the capabilities for the platform to be able to grow into these other things that we can't even anticipate yet. There were also new inventions or ideas, the ability of notifications to tell you what was going on in other applications and experiences, even if they weren't running at that time. Everybody was coming from a desktop world where there's monolithic applications that do everything, but the team realized, well, there's going to be little micro apps, and those micro apps are going to be very focused on specific things that they need to do, and the ability for you to get information from all of those different experiences and to be able to navigate with multitasking very easily back and forth between them is going to enable this as a much more powerful device than if we just tackle it as a small desktop where you're in one application, you have to do everything there, or it's a pain to go back and forth between these things. And then finally, security was important. It continues to be more and more important. User security, data privacy, all that stuff.
Except for that little bug. How many of you have heard about the root bug from Android 1.0,
awesome.
if you remember? Okay, a couple of folks. So it was interesting. Like, people were trying to root their device, and then there was this like myth going around online that you could just download this terminal app from the Play Store, from Market, and just type SU basically and log in as root. And we're like, that's not possible. Like, we don't run the apps with the permissions that let you do that. And then we started seeing people that said you could do the same from Gtalk, right? From like the messaging app. And we're like, okay, that's not normal. Like, there were people rebooting their device by typing reboot in their text app. Turns out that the kernel team had built all that security stuff, but they had left a TTY console. Linux, even when you show the graphics display like X11, you can have a terminal running. So they left it open, and all the keyboard events were sent to that terminal with a lot of more permissions than it should have. So actually, when we were typing anything on Android, it was going to a terminal. So if you type like, sudo like rm-rf/, you could wipe your phone. And we would just let you do that. So it's like we had built this amazing safe, this giant door, like with security and biometrics. We just forgot the walls around it. We fixed that pretty quickly.
I think that was in 1.0, and that was fixed by the 1.0.1
And my favorite part about that was the kernel team was always telling us, like, framework people, like, oh, you don't care about security. And so that was kind of nice to like show that to them afterwards.
But the piece that they did build in at a very low level was taking the idea of user IDs, which came from other operating systems, including Linux that was built on for the kernel for Android, where I, as a user, will install applications, then applications run as me, and then those applications have all the rights and permissions that I do. Kind of makes sense in a desktop world. I installed this application, I installed that one. Wouldn't it be nice if they could just run as me with all the permissions that I've given myself as a user on the system? But on a phone, they realized, no, micro apps, and micro apps can't be trusted. They shouldn't be running as the user. Instead, they should be running as independent users. So they took the idea of user IDs from the Unix operating system fundamentals, and they said, actually, the applications themselves are the users. So you, as a user, install this, but then that application will run as its own user, which is completely sandboxed from every other user or every other application on the device. So this was sort of built into the system at a very fundamental layer. There were other bugs, maybe, that had some security issues, but they did realize very early on security is going to be pretty important here.
The choice that the team made for developer tools proved out to be a good one. So picking Java was painful. Like, the first version of Android shipped with a runtime that was only interpreted, so there was no ahead-of-time compiler, there was no JIT. So it was a constant struggle to write the code to be efficient and performant on the slow-end devices. And if you've ever looked at the code of the platform, you might be surprised by what the Java code looks like in practice. It looks more like C than Java, with like manual inlining and these kind of macro optimizations, because they made a huge difference on the devices back then. And for several years, we thought the GC was extremely expensive. It was pretty common, like when you got a GC pause, it could last 200 milliseconds, which was obviously bad for the user experience. And that's why a lot of our APIs let you pass in pre-allocated objects so we can avoid those extra allocations. Of course, things are a lot better nowadays. So it took a while for this choice to really make sense. But I think today we're all happy to be using something like Java and Kotlin instead of C and C++ or assembly or whatever. And then, of course, Android Market. Android came out with a marketplace where you could publish your applications. It was pretty easy to get your applications on the store and for users to find applications, which was really key, as opposed to other ecosystems where there would be many, many sources for applications, and a lot of them would be untrusted.
And then finally, there's the area of business decisions. Here we go. So first and foremost is the decision to go open source. There was an interesting dynamic, still is, where if you want to license your platform or even give your platform away to other companies, the other companies may not want to license it because maybe that's going to cost more per device that they want to ship it on than they want to pay, and that's going to cut into their profits. So this is like the WinCE model at that time. They were charging it per handset, and all of the companies that bought into that platform would then have to pay some number of dollars per handset, and that was really tough to make a profit on after paying that. But the other dynamic is even more important, which is why would that company trust where you're going with that platform? They need to make a business decision, allocate their own future resources based on something that they have no control over. So people coming from Palm, for example, went through the experience where they built this amazing operating system and they worked with partner companies to then launch devices based on it, and eventually the partner companies just walked, because they didn't know where Palm was going, what the future of this operating system would be, so why would they bet their future on some other company they didn't control? But if you go open source, it doesn't matter, right? It's basically free code that's out there for everybody to take and do whatever they want with it, right? So the ability for the platform to say, here's the code, it'd be really nice if you were part of the ecosystem, but then that company could say, okay, yeah, that sounds good, and by the way, if Google goes out of business next year, I don't have to care, right? Because they still have the code. They could fork it, they could walk, they could do whatever they wanted to, and so that was one of the key dynamics in the business decisions for Android that made it possible to then talk to all these partner companies, because they didn't have to care about Google's vested interest in this platform, because all of the code in the platform was going to be available for them to use regardless.
One interesting thing when Chet was writing the book and I was helping him with the interview, so we interviewed a lot of the folks who were there for Android 1.0, and the question that Chet asked every time was, why do you think that Android succeeds, right? Like it would be interesting to see what everyone would have to say, probably expecting different answers. And pretty much everyone, including myself, said the same thing. We were at the right place at the right time. And there are many reasons for that, right? Like first of all, like the mobile hardware. Like when Android started, and I was part of the pitch deck that Andy Rubin and his co-founders had, which was the hardware was getting good enough. We had all those sensors, you had good enough batteries, the touchscreens made the devices more interactive, the screens were getting bigger. It was also getting cheaper, so you could build those smartphones at a price that was attainable for most people. But yeah, it's and you can try to like anticipate some of that, but up to a point, and we're going to talk about this in more detail in a little bit.
And another one that it is not as obvious in timing is the iPhone was launched. I think like the immediate reaction you have to knowing that the iPhone came out at that time was, wow, that's killer competition. Absolutely, still is, right? Good company, ships really good consumer technology, and this is difficult to compete with, and it's a factor in the industry. On the other hand, think about it. There was one manufacturer shipping phones that benefited from the iPhone. That company was called Apple. So if you're Samsung, if you're HTC, if you're LG, if you're whoever, if your name is not Apple, what are you going to do? So there's a new market that was created of this new evolution of smartphones, and if you're not that company, if you don't have a platform to ship a competing product like tomorrow, what are you going to do? So this opened the door for all of those companies that were going to go their own direction to come to Google and say, hey, I heard you have this thing, maybe this will work for us.
So we have another quote from Ficus, who's really good at being quotable. So anytime anything works out, if you don't acknowledge the huge luck factor, you're kind of a jerk, right? You can be. We believe that when you succeed, like of course you worked hard, of course you're smart, of course you're surrounded by a great team, and you had the funding or whatever. But luck and timing is a huge part of it, and again, I think Chet said earlier, right? How many amazing projects have you seen from well-established companies that don't go anywhere and that fail? That's not because they're necessarily bad at what they do or the product was bad. It's just timing. Like the timing, you may be too early or you may be too late or other reasons.
All right, so finally, 40 minutes into this talk, we get to the point of it. Why do projects succeed? What can we look at in the history and some of the dynamics in Android success and extract ideas that may contribute to generic software or technology projects succeeding in general?
So the first one, and it's a pretty obvious one, is your vision. You have to really understand your vision, know what you're aiming at, and carry that through. So in the case of Android, it's interesting, right? It started as a company that was trying to build something for digital cameras. But the real vision was to build an open source platform and an entire ecosystem. They happened to pivot to phones, but they built what they wanted to build originally, which is an open source platform with an ecosystem. So that was the vision, and they could have done it for other things. I think the scale of the success here is only because they targeted smartphones. They could have been successful at a smaller scale if they had targeted maybe cars or whatever, but the vision was the same. What was also interesting is that from the beginning, Android always tried to build a platform and products, right? So today we have the Pixel devices that are built mostly in-house or all in-house. But before the Pixel, we had the Nexus devices. And before the Nexus, we had the T-Mobile G1 and the, I don't remember, I only remember the code names, not the marketing names of the phones. But we were always building a product along with the platform so we could ensure that what we were building in the platform was something valuable to the users, to the developers, and also something that worked, right? We had to ship actual product. We had to make sure the battery life was good, that performance was good. So that was extremely helpful. And there were other companies in the past, like, for instance, PalmSource and Symbian, who were building only the operating system, right? They were partnering with other companies who were building the products, but they were not building the products themselves.
It's also important to have focus on what it is you're trying to do. So this relates to me saying, well, the team was not only small, but it was also purposefully siloed, right? The ability for the team to just look inwardly and say, okay, we're racing at this goal and we're going to try to meet it no matter what, was really important, especially given that tiny window of opportunity that they had. It not only helped drive sort of, the vision and the intensity that people had toward trying to make this thing succeed, but it also built loyalty to the product and the team, which is otherwise kind of difficult. When a company gets acquired, I've been in large companies that did a lot of acquisitions, most of which could generously be called failures. And one of the huge dynamics is you bring in this company, they have this amazing tech, they have these amazing people, and it just kind of goes entropy on them almost immediately because these people get pulled into other projects, or they take their stock options and they walk, or they get sucked into meetings, or they can't figure out how to integrate this product vision with that, or the culture is mismatched, whatever it is. And Android basically just sidestepped that whole thing and said, we're going to continue running as our own startup within that company. And that allowed the team to just focus exclusively on what it was the team was trying to do with that original vision, instead of getting pulled into what else could we do with Google. There were teams at Google who were trying to do that at the time, like, hey, we really like where you're going and we'd like you to be part of, and the team said, nope, not right now. Why don't you come back after we've actually shipped and we'll have that conversation.
Next, it's to have the right people. So you want folks who not necessarily fit the company, but fit the project. And I think Android was a perfect example of that, where you had a web company, a search engine company, and you need someone to build a Bluetooth stack or a graphic stack. You may want to hire someone who knows a thing or two about this kind of stuff, right? Who has some experience in that area, knows what not necessarily knows what to do, but at least has some ideas of what not to do. And it was interesting because a lot of the folks, especially the early folks on Android, did not fit the typical mold that Google was looking for. In particular, I think a lot of folks on the team did not even have the college degrees or even high school degrees. And there were folks like Hiroshi Lockheimer, who's now in charge of Android, Chrome OS, Google Photos, massive projects at Google. I think originally, Google did not want to hire him, and Android had to insist.
15 interviews and an essay.
Right. So, because and it's also a personal lesson, right? Like because if you interview somewhere and you get rejected, that doesn't say anything about you, right? That doesn't say anything about you. And so yeah, it was very valuable to have the right experience, to have the right vision, right? Having folks like Dan Hackborn who knew where, or at least could anticipate where the industry was going, so they could put in place the foundations that would be necessary to build the right apps, to have the right compatibility, to build that ecosystem. That was what was the most important thing above everything else, right?
The next one, I mentioned this earlier, certainly if you're shipping a platform, the ability to be open source. I mean, obviously there are different profit motives and things you need to do for the bottom line. This happened to work out for the incentives that Google had in this area. But the ability to be open source meant that they could attract the interest of companies out there that weren't Google, right? Because that allowed that trust to build where it was going to be an open ecosystem instead of some closed platform that then these companies would have to buy into Google's business vision for the future instead.
So this one is a little bit more difficult, you know, as a manager myself, to talk about this. So crunch times do happen. Like you want to avoid them at all costs, and as a team, you know, we try very hard to avoid them. Like that's every time they happen, it tends to be a failure of planning and not a failure of individuals. But you know, they might happen, and sometimes you may have to do this extra push. What definitely should never happen is what death marches, right? You don't want to do that over long periods of time. Android, in another way, I don't think is a good example of what to do, because we worked, I mean, when Chet said that we worked hard, I think you're underselling it a little bit. I mean, for a year, I think 2008, I was easily doing, you know, 50 to 100 hours a week, every single week. That was, yeah, I do not recommend that to anybody. But it's also hard to, you know, to say that it was not helpful because the project was successful. Could we have been successful in a different way? I don't know. I'm not sure. All I know is that you can be without doing this, and we try very hard to do that. And since like 2010, Android has managed to remain successful without having this kind of like, you know, insane workloads. There is crunch time from time to time. Like again, they're bound to happen. They're failures of the organization, but they're bound to happen, and you should expect them and know how to deal with them.
Competition is good in a couple of ways. One is it does spawn innovation. The fact that there is someone running right next to you or right behind or right in front means you need to come up with really good ideas to attract users and to make your products relevant in the market. I think that is the case no matter what domain you are in the market. I think that it's really good to have competition out there because it makes you think more and it makes your products better. But it also is that weird thing where I didn't really realize until I thought more deeply about it, where the competition was specifically good for Android because Apple was there. Because yes, they built this amazing market for themselves, but by doing that, they drew a really solid line that created a market for everybody else. All of those other manufacturers, all of the carriers that weren't chosen by Apple in their markets needed to do something. So competition was really good in a way for Android and could be good for other people too, because it actually creates markets at the same time as it makes some markets harder to attain.
Next is just keep going, right? We talked about the road to 1.0, but obviously that was just the beginning. 1.0 was we cut as much as we could to make it to market, right? We talked about timing. There are some amounts of timing and luck that you don't control. Some you do control, right? We had to come out, the iPhone had come out. We need to respond quickly. And so we were cutting every week towards the end, the last few months, we were cutting features constantly, all the time. And it was, I remember Andy Rubin would walk in my office like once a week and I would look at him and be like, okay, what do I need to remove now? And that's difficult, but that's to set you up for future success, right? And then you have to keep going and not stop just because you're being successful. And you can see, you know, or what we see internally, Android is well established. It has a huge market share, but you know, if we stop, like someone's going to replace Android eventually, right? So we need to keep innovating. We need to keep making sure that we make your life better, so you can build better apps, so we have a better ecosystem, and that's really key. Like, do not stop.
So who in the room thinks that Android APIs are perfect as they are? Let me keep your hands up. There's one and two. I didn't think I'd get that many.
Well, what do they know?
Okay. So I've been at companies that have spent a very long time trying to come up with the perfect solution, and then in the meantime, someone else comes out with something that's good enough. And that's the lesson here. You need to ship something. The fact that Android shipped 1.0 APIs that are, in many cases, ugly, undocumented, insufficient, needed to be fixed or deprecated later. The fact that they shipped anything means that we're still here today.
Well, and there were other aspects, right? The UI was not the most visually pleasing, but we had multitasking that didn't really exist on mobile devices. We had push notifications, which was amazing, right? Like having that device in your pocket in 2008, where you could get push notification from your email app and your messaging app, and being able to switch back and forth between both didn't exist. So yeah, we had to make some concessions and we made a lot of mistakes, but the value we were bringing was good enough to overshadow the less successful parts of the platform.
And the fact that it was successful enough that we're still here today means now we get to spend our time trying to polish some of those earlier mistakes and make some of those APIs better over time. And that's better than not being able to ship anything at all.
One way I like to put this is like you have to know which corners you can cut, right? Like you will have to take shortcuts to get to market and to be successful. There are some that you can afford to take and some you cannot. And it's very interesting. So I mentioned, for instance, display independence, right? Like the DPs and the layouts. To us, it was not a shortcut we could take because it would become very important, especially for Android that was supposed to run on so many different devices. But then there are other things where, we were able to replace like a huge chunk of the implementation of the system over the years because we had taken corners in those areas, but we could afford to do that because then later we could come back and fix it. But, not introducing layouts would have been very painful. Timing, I think we talked about this already. So you can't control it. You should be aware of what's happening, and you can aim for a window of time, and you have to be able to react very quickly, right? A great example, again, is like the arrival of the iPhone. We had this sooner device. It was canceled. We accelerated the Dream device. It changed the timeline. The teams were able to like switch to the new device like instantly, and if you ignore what's going on around you, then you're going to show up on the market with like a device that's already irrelevant or a project that's irrelevant.
So closely related to timing is the factor of luck. Also not something you can predict, maybe something you can take advantage of if you see it's there. But it's also important to realize, like, if your project succeeded, as Romain said earlier, yeah, you're probably really amazing and you worked really hard and you had a really good idea. On the other hand, there is a luck factor and you have to kind of acknowledge that. If you're on a project that doesn't succeed, as I think I can claim to have most of those throughout my career.
So many. You're so
many.
bad.
And I'm sure partly my fault. But
All your
also
fault.
there is this undeniable factor of like, well, maybe it just wasn't the right time. It wasn't the right tech. It wasn't the right audience. You didn't have, all the right ingredients coming together at that time. So what do you do at that point? You just put that away and you start something new and you try again over and over and over.
Until you succeed or you retire.
All right, so we wanted to very quickly at the end just kind of fast forward and say, okay, well, where is Android today? So first of all, let's talk about some of the release timelines and how those have changed over the years.
Oh, I'm supposed to talk about that?
Yes,
That's a new slide too.
It is. Isn't that pretty?
Well, I guess the main point here is, we talked earlier about like you have to keep going, right? Like Android 1.0 was a little rough around the edges, and you can see like here all the different releases that came out in the early years, and you can tell that we were working at a ridiculous pace. Sometimes doing things that still don't make sense to me. Like you may have heard this anecdote before, but we finished 2.0 before we finished 1.6, even though 2.0 came like after.
It was the reverse Polish release.
Yeah, I still don't remember why nor how we did that. And then we were doing 2.3. We released 2.3 like halfway through 3.0. That also made no sense to me. And we did a new UI for 2.3 while we were doing a new UI for 3.0. Again, makes no sense. But since then, once we reached the point where the foundation were laid out, we had a good, solid foundation that we could rely on, then the releases started making more sense, right? Like it's once a year, a major release. It's a lot easier to plan for it. We can avoid the crunches and the death marches and so on. We can still react pretty quickly because a year is not that much anymore when, the innovation in the market for smartphone is still there, but it has slowed down considerably compared to 10, 15 years ago.
So we thought about sort of ending up with, okay, well, where is Android at now? What's new in Android? But frankly, I/O just happens, and there's a talk called What's New in Android. Go watch that. right? Someone else can talk about sort of what's going on in the modern thing. I think it's a little more interesting to sort of stay on target here and say, so why do projects succeed? And we wanted to take a look at one particular modern Android project and say, okay, what were the elements that we've talked about today that maybe contributed to this project existing in the world
So
today?
let's talk about Compose, and I think there are a few folks from the Compose team in the room, so hopefully I won't say anything stupid about their work. If I do, please come find me after and yell at me. So first of all, the vision. So the story of Compose, I don't know if we've talked about it a lot publicly, but at some point we should, because a lot happened. If we rewind back like about 4 or 5 years, Chet, who was managing the Toolkit team that I now manage, was talking with his team, and the team had this idea of like unbundling the views from the platform, right? The idea was, how can we deliver bug fixes and new features to you faster, more often? Well, we have this Android X thing. How about we do that for views? As they started thinking about that,
It was called the Great Widget Migration.
or Gwimi, fantastic name. That the name
Best product
yeah,
name ever, which the team didn't like for some reason.
and they still talk about it, and I think they're wrong. Anyway, but once the team started thinking about this, suddenly you start thinking, well, if I'm unbundling the views, and maybe I could fix the APIs, right, and make the views better. So the project started taking a different direction. And when you start thinking that way, it's like, well, how about we start building a new toolkit, right, from scratch, that's easier to use, that's better. At the same time, we had someone working on an experimental Compose compiler plugin to bring a reactive model to the view system. It was using like embedded XML syntax in your Kotlin code, and it was generating views. And then at some point, Chet and I were like, well, we could take those two projects and make them one. So that becomes something else that we're calling Clutter. So that's basically, Flutter-ish because it's reactive, but in Kotlin. And then we kept iterating on that, and it became the Compose that you see today. But the point was, we were trying to find our vision, right? But once we found it, which was, okay, we're going to build an unbundled toolkit, and it's going to be reactive, like that became the sole focus of the team, and then we took several years to make it become a reality.
I think there was a really important lesson for me in there too, that the project, like, it was super interesting for a long time, but it was kind of going in circles until we had that codifying vision, right? Like, until we actually declared some place to go to, which was the reactive framework, we kind of just populated the room with really interesting ideas, but didn't make a lot of forward progress. So actually having a really clear place of where you're trying to end up, even if it's not the best place, again, ship something, right? Give the team something to focus on, and that allows them to proceed.
Yeah, and the key is because for pretty much anything that we do in the software industry, there's not a single solution, right? Like there's not the answer. And certainly a UI toolkit, you can build a UI toolkit in a million different ways with like different architectures and API designs and so on. So you could spend a decade trying to figure out which one you like until someone sets a vision and or the team sets a vision and says, okay, no, we're gonna do it this way, and that's it. We pick a direction and we stick with it.
So related to vision is focus, the ability to actually say, okay, this is what the team is working on. At first, it was about 4 or 5 of us getting together on a regular basis and doing those sort of iterations on ideas and then codifying, okay, this is what we're aiming at now. And then it was more of the team. So some people were responsible for, maintaining or continuing to develop the other things that were really important, but some teams were just focused exclusively on this is what we are trying to come up with here, and they really needed that without the distractions of like also going to architecture meetings on that and also making decisions on old view hierarchy, blah blah blah. But it was the ability to just say no, Compose is the priority here.
Then having the right people, obviously some of us had been around for a long time and we have worked on toolkits at Google and at previous companies. So it's extremely useful and valuable, especially with the view system, right? Like folks like me who have been working on it, I know where all the corpses are hidden and things that are way worse than corpses.
You killed most of them.
Yeah, they keep haunting me. So we have a good idea of like what we should not, like what mistakes we should not repeat. So for instance, the reason why Compose is built as a set of layers where we let you reuse every layer, if you don't like our material button, it's super easy for you to create your own button because we learned from experience, right? Like that's not how the view system works, and customizing the view system is incredibly difficult. So that's a mistake we made and we did not want to repeat. But, and equally importantly, we also did not want only folks who had worked on the view system to work on Compose. We wanted new ideas, new perspective, right? Like, because otherwise we're kind of bound to recreate something similar and probably, not as good as it could be. So a lot of the folks we hired on the team came from, some folks came not from an Android background. And it was amazing to see the kind of ideas and perspectives they brought to the team, while, more experienced folks like me could just watch from afar and just say, hey, you shouldn't do that because, there's a reason we did this way in the views, and I really think you should keep that. But everything else, right, like those new ideas, it was amazing to get that from new folks.
The open source aspect kicked in for Compose because this was developed at a very early stage in the open, and we were able to get ideas externally and find out how it was working for people so that we could iterate toward 1.0 with a really good idea of how to get there with an API that people would use. For something as large as Compose, like this is the future UI toolkit of Android. All that stuff you've been using since 2008 is the stuff, it works really well. I'm glad it's working for everybody, but in the future, everyone will be using Compose. So how do you move an entire industry over to this new thing? Well, it starts with maybe taking those baby steps and saying, here's the new thing, please try it out, please give us feedback, so that the thing that we actually release is the thing that you need and the thing that you want to use, not just the thing that you feel was forced on you by people who weren't listening.
Well, although we had that that one time when we asked a bunch of developers, as we were really starting the project, we asked if all of you wanted a new UI toolkit, and the answer was basically no. And we decided to ignore you because you were all wrong. And I'm sure you're glad that we ignored you. Working hard, so the team has worked really hard on Compose, but we did a much better job than Android 1.0 at managing, crunch times. They happened a couple times. For instance, when we shipped Compose 1.0 beta, there was a big push to get to the beta. But otherwise, we try to be as reactive as we can in terms of planning, cutting features, postponing them, reassessing. For instance, just before 1.0, we ran into this performance issue. We were able to, some folks had to put in a bit of crunch time to get it to where we want it to be. But at the same time, we postponed the release by a couple months. So instead of showing up at Google I/O, it showed up a little later. So we try to find the right balance. I'm not sure if we always succeed, but it's part of the equation.
Competition is always really important, as I said. In the Compose world, it was important for bringing in new ideas. I have worked on a lot of UI toolkits. They all kind of have a similar flavor. And so my solution would always sort of fall in that same groove, right? Without the ability for taking in ideas into the team that were coming from elsewhere and going, oh, maybe that's another approach that we could use, I'm not sure that we would have come out with something that would have been as modern. Instead, maybe we just come out with a different variation on the thing that we already had.
Shipping, so cutting features, right? Like we constantly reassess like what goes in which version of Compose, and certainly for Compose 1.0, we had 15 years of development to catch up to, right? Things like right to left support and focus and keyboard navigation and mouse support and trackpad support and all those things. You can't do everything all at once, so we had to focus on a subset of all those features. And so because on my way here, someone on a French Slack was asking me, they're trying to use Compose on TV, and they're like, well, focus navigation doesn't really work that well. And my answer was, yeah, because, that's one of the things that we decided to cut for the early versions of Android. We're working on it. We know that we have to do it. But that was the way we could get you to a Compose 1.0. And getting to a Compose 1.0 means we're going to have 1.1 and 2 and so on. And you're going to get the features you actually want. So be patient with us.
Just do keep going. As I said, we sort of iterated in a closed room for many months trying to come up with a vision. Once we had the vision, there was still a really long road ahead of us, but we just kept focused and kept going without launching anything for a very long time or even getting close to 1.0 and saying this isn't quite right, so let's delay a little bit so that we can launch the right thing. But the team just kept going to actually deliver the thing that was the original idea to begin with.
Timing, again, things that we could anticipate, but not everything, right? Like when we started Compose, well, Kotlin was becoming very popular amongst our application developers and becoming really good. They were ironing out some of the issues. So we showed up at the right time. We happened to have Kotlin compiler plugins, which enabled Compose to exist as it does today. And then there were also internal timing that worked out really well. Like at that time, so it was 2017, 18, The platform was pretty mature. The view system was really mature. Mature design was there. So the team, we had a lot of bugs and feature requests and so on, but there was no massive project that required our attention. So we were able to divert a lot of our resources to compose and kind of ignore the existing stuff. Now, last year we had Android 12 with this brand new UI called Material U, right? If we had tried to start Compose at the same time as Material U, there's no way we could have worked on Compose, right? Like there was too much to do for Material U. So we picked, we got lucky with the timing in many ways. We had the right language, there was the right competition, we had the right timing internally, so we could divert those resources, and it worked out well for us. Not sure we could repeat that.
And again, related to timing is the luck of having all the right things come together at the right time, whether it was the compiler technology, the type of reactive programming that people seem to enjoy, the use of Kotlin, the adoption of Kotlin by the community, everything sort of kicked in, fortunately for the project overall. So I'm looking at, so there's one final slide, and I'm looking at the time, and Greg had said, hey, you have plenty of time. You have all the way till 11. We thought, well, we gave a version of this talk in 30 minutes just last week, so that means we'll have plenty of time left over for Q&A. And then it turns out we just expand to fill all available space.